Hello everyone, welcome to another edition of my GIS tutorial. Today we'll be covering advanced mapping technology using QGIS. So what will be done in this project is we're going to create a project folder. Then as well we create a QGIS project. We're going to insert base maps, install plugins, then we're going to delineate boundary for our new city, which would be the objective of the project. Then we're going to use Quick OSM to import some footprints of buildings as well as road network, export our map to JPEG format. So let's get started. So before we start the project, we have to create a project directory or a project folder. We click on the desktop, we go to new and click on new folder. Let's call the name of this GIS project just GIS project. Simple. Then in this GIS parent directory, we create other subdirectories. So we can create a folder called raw data. This raw data is if we have a field data collected, we're going to insert it in the raw data, which can be used to import into our project. Next, let us create another folder or subfolder called processed. This processed folder is after we have generated our map, we're going to export it into the processed folder. That is the final output of our map is going to be saved under processed. Again, let us create another folder called shapefile. This shapefile folder will have all our shapefiles being saved into this folder. So this is the project folder. So we now open QGIS. We go to search, QGIS desktop. So when the QGIS window is being opened, we're going to see some series of projects or previous projects. So since we're not going to work on any of these projects, we're going to create a new empty project. So we double click on this empty project. So now we have the display window, we have the browser window, we have the layer window. Should you never have any of these windows, let's say for example, you open your folder, you didn't see any of this, we have to close this. For example, if your display is like this, we're going to view, then we go to panel, then we try to toggle on the browser, the first browser, then we can see our browser window. Next, if we want to see the layer window underneath the browser, we go to view, we go to panels, then we click on, we check in the layer. So now we have the browser and the layer. So next, what we're going to do is to bring base maps for our project. I have already configured series of base maps which have been saved under XYZ tiles. This was done in Python. I can develop another video to show you how it was done. So if I expand the XYZ tile, I will see a couple of base maps. So let's toggle through OpenStreetMap and click and drag, then we have OpenStreetMap. So our project is going to be developed in a country called Sierra Leone. Let us zoom to Sierra Leone. So next, what we're going to do is to toggle through the coordinate system. So let's look at the type of coordinate system that is available for Sierra Leone. Of course, we have two types of coordinate system. We have the geographic coordinate system and we have the projected coordinate system. The geographic coordinate system uses WGS 84 as reference. Then this is the EPSG ID code, which is 4326. For the projected coordinate system, we have two zones. That is UTM zone 28 north, which has a reference ID EPSG European Petroleum Survey Group 32628. Then UTM zone 29, which is EPSG 32629. So there is common thing that you need to know when you look at this coordinate system. One is the EPSG ID. For WGS 84, you will only see 4, which is the WGS 84. Then we have a common digit 326, 326, and 326. So you will know where I want to go for now. That is, we have understood that the WGS 84 only has 4326. It has everything. Then we have the projected coordinate system, EPSG. It only starts with 326. Then the end, the two digits, the two last digits has the code of the zone, 28 knots, 28 knots. 29 knots, 29 knots. So this is for simplicity for folks that want to get it as quickly as possible. So these are the IDs. So for 28 knots, it's not 4, but it's 326. 326, which is 326, then you add the zone that you want. So this is necessary for you to search the type of coordinate system which we'll be doing. So next, our project is going to be located in UTM zone 29 north. So I guess folks will now try to understand which coordinate system we're going to use. For us to toggle through the coordinate system, we have the default coordinate system, which is being brought by the base map that is being imported. So we click on EPSG, this is 3857. So we will see that the default here, which we have, is WGS 84 3857, and the bounding color you see in here encompasses the globe, which means it is not a projected coordinate system, but it is for the entire globe. So what we're going to do is we want to search in for 29 north coordinate system. So we search using the ID, which is 32629. Then you will see the UTM projection. So once you click this, you will see that there is a shaded region here that tells you this 29 north is on the right half of Sierra Leone. So if, for example, as well, let's click this and click on OK. So we have now projected our map to 29 north. Let's say, for example, we want to project to 28 north. I think folks now understand what we're going to do. So we use 326, 28 north. Then we have UTM zone 28. If you try to toggle through, 28 north is on the left part of Sierra Leone. So if we click on OK, then we have projected our map to UTM zone 28 north. But since our project area is going to be based on the 29 north, we are not going to search anymore because we have the recently used coordinates. So let's just click on 29 north and click on OK. So next, we're going to download plugins which will be used for this project. Two types of plugins that will be used are the long lat or lat long that can be used to search for places. Then as well the quick OSM, which can be used to extract footprint of our buildings, as well as road network, river network, and the like. So we go to plugins, manage and install plugins. You need to have internet connection. If you don't have internet connection, you will not be able to download the plugin. So we search for lat long. It's a two-word, so I never have it, so that's why you never saw anything like check mark here. But if you have it already, you will see check mark. You don't need to download if you have it. I don't have it, so I'm going to download it. You click on it, then install plugins. So when the lat long is being installed, you can see it here. If you come with your mouse, you will see lat long toolbar. So these are the couple of tools that will be used on the lat long plugin. We again go to plugins, manage and install plugins. Then we download quick OSM. It's a one word. I don't have it, so that's why it's unchecked. So if I click on it, I click on install plugins. Depending on your internet, it will download as fast as possible. Yeah, so now we have the Quick OSM plugins being downloaded. So you can see the check mark here, then we can close. This is the symbol for the Quick OSM. So next, what we're going to do, we are going to navigate to our project area that can be used for this analysis. So what we're going to do next, we come to this lat long tool. Then you will see there is something called zoom to coordinate. I already have the coordinates that I want, so I will have to search for it and navigate or zoom to the area of interest. So I just come to this single point, which is zoom to coordinate. If I click on zoom to coordinate, you will see a wizard appearing here. It tells you you have to enter the 29 zone 29 north projection coordinates that you have. For me, I have already the 29 north coordinate. It's a single coordinate. So the x, the distance is 207021, 207021, followed by comma. You will see how it should be written here. You write the x separated by comma, then you write the y. So I've written the x separated by comma. I'm going to write the y, or the instance. Sorry, nothing. It's 954, 954, 925, 925. Then I hit on enter. So you will see there is a crosshair here. I will have to zoom to see where this point is. Oh, this is Makali. So there's a town called Makali, which is located on the Makeni-Kono Highway. So this is going to be the project area that we're going to create an example on. So I like this example because we have the names of the streets. And yeah, so what next we're going to do is to delineate the boundary shapefile, which is going to be a polygon for our Makali town or Makali city. So to do this, always you have to ensure that your map is being saved. For now, our map is not saved. You can see Untitled Project at the top. So let's go to our browser and minimize this XYZ tile. And we have home. There is a home folder here, which is on the browser. If you extend it, you will not see your project folder which you have just created. This is just the home for your computer that was for which it was installed. So you cannot see any of this. So what we're going to do is, you can observe that if we save this project into our working directory called GIS project, you will observe that this home is going to change to green and gives you project home. So for example, let's say we're going to save our project. We hit on the save button, then we navigate to our desktop. Then this is the GIS project. Let's click into the project. Let's give the name of our GIS project the same name as the project folder, GIS project. This is the QGIS file. It's named GIS project. Then we hit on the save button. Then you will observe we have now moved from ordinary home folder to project home. So if you extend or expand this project folder, you will see the couple of folders that we have created, the process, the raw and the shapefile, and the new GIS project, which has just been saved into that project. So folks, I guess this is well understood. So for now, we can close the zoom to coordinates because we have already located where our project will be. So we close on this. So for us to create a shapefile, because this boundary that we're going to create, it's a shapefile, it's called a polygon shapefile. You have to understand one thing. You need to select where the shapefile will be saved or where the polygon will be saved. We already created shapefile here, nothing is here for now. So this is where we're going to save our shapefile. So that's why when we created this, we right click on it. That is, we're going to save it here. So you right click, you go to new, then you go to shapefile. Then under file name, do not do anything here except the name of the file that you're going to save. So because you are saving this shapefile into this project shapefile, that's why you're saying the folder path. So we're only going to rename the layer, that is the shapefile that we're going to create. So this shapefile is going to call Makali City. Let's call it Makali City. Makali underscore city. Done. So file encoding, we leave the default geometric type. Geometry type is, we all know we're going to create a polygon, so no worries, let's click on polygon. That's all what we're going to do. And don't forget, we are working on the coordinate system. This is geographic coordinate system. We want to we want to be consistent to project our shapefile. So we project it to our 29 north. We click on this globe. Then we already have the 29 north. We click on it, which is 32629. Then we click on OK. So this is the projected coordinate system for our shapefile. So new field, the field is going to be the column names that will be in the shapefile. So for now, folks, let us just limit it to the name of the field as well as the area, because we're going to calculate the total area for our boundary or for our shapefile or for our city. So we're just going to use two key fields. This ID field is the default that is being brought, so we can leave it. So for us to create another field, we call it the name field or city name. Let's call it city underscore name. And the element that will be saved under city name is text, because we're just going to write Makali City. That is text. So we leave it as it is. We leave the length. Then we click on add to field. So we have got city name as a text or string. Then the total length is just 80. This is, let's leave the default. Then we as well create another field called area underscore, because the area is going to be calculated in square kilometer. Let's just say area km2 or km square. Then it's not going to use string or text. We're going to use decimal to save the area. Let's say this area is just something like 2 digits, point another 2 digits. That is the first significance figure, then the decimal point. So the total character that is going to be here, let's say it's 5, because it's, for example, let's say it's 25.63, or let us limit it to something like a 6 character, because maybe the area might be up to 3 figures. So let's say 6, maybe it can be 326 points, so that's a 6 length or 6 character. So the precision, that is the decimal point, let's just limit it to 2. Then we add to field. So now we have the area in square kilometer. So we click on OK. So by doing this, we have created a new shapefile called Makali City. You will not see it in the layer, but if you look at the shapefile, you are going to see the shapefile being created. So we bring this Makali City into our project. So we right click and drag into our project. So this is the Makali City. Folks, don't expect you to see the boundary automatically, because you never created any boundary. You didn't do any edit. So you just created a layer that can have a city that is going to be digitized. So for us to have the boundary for the city, we're just going to start editing, because we have already created this Makali City. Nothing is here. If you open the attribute table, we will just see the fields that we have created, the ID, which is the default, the city name, and the area in square kilometer. Nothing has been created, because you have never inserted or digitized anything. So you can toggle through the field orientation. For some folks that you can't see it like this, you will have to maybe it like this. So you toggle through the horizontal or the vertical alignment. So we close, then we're ready to create our shapefile. So next, we have created the shapefile, we're ready to digitize our boundary. So to do this, we have to start toggle editing. So for us to start this, we right click and go to toggle editing. After you click on toggle editing mode, you will see under editing something has appeared here, which is add polygon. Because this is a polygon, then anything you create, you're going to create a polygon. So if we now hit on the add polygon, then you will have a crosshair which will allow you to digitize. It won't be perfect, but let's just maintain and see what will be derived from this boundary. We're going to use the footprint for this shaded region. So we zoom in, we just try to click. It doesn't matter if we don't have the perfection. Make sure you have to use your mouse for you to digitize properly, because if you don't have a mouse, then you will get into trouble. So we click on the boundaries, shaded boundary. I'm just trying to zoom in and zoom out on the mouse so that I can see. So for folks that might want to pan, we have to hit on the wheel of the mouse for you to pan. For example, if you hit on the wheel, you will have the hand. This can be used for panning when you want to digitize. When you release your finger from the wheel, you will have the crosshair. So we continue to digitize. Digitization, I'm just left clicking. Then I have to zoom in and zoom out for me to see the extent of my boundary. So for me to just get some time, let me just do it fast. Excellent. So this is the starting point. So this is the end of my boundary. So once I'm done with digitization, I hit on the right mouse button. Then it will ask me to insert some of the elements which I need to know. So for example, you know, these are the fields created. I have to type in the name of the city. So this is called Makali City. This I'm not going to use any underscore because it's an element I'm going to write. So for the area, I cannot say this is the area. The area is going to be calculated automatically from the GIS. So I hit on OK. So once this is done, you will see a nice boundary for our Makali city. So this is the city, and for folks that do not want to see this color, we're going to change it. So we can hit on the Makali city and toggle editing as well for us to save our edit. So if we want to only get the outline of the city, not to have the fill, we right click on the Makali city, we go to properties, then we go to symbology, then we click on simple fill. Then you can see fill color. We don't need any fill color. We just want transparent. Oh, transparent is here. We click on transparent. So we don't want any fill color. Then the stroke color is going to be the outline color. So for this, I'm going to select maybe something like dark red. And yeah, click outside. So depending on the stroke width, I'm going to see whether it's been thick or thin. So I'm going to increase it to something like 0.6. Then I click this above so I can see the OK tool. When this is done and I'm OK with it, then I'll click on OK. So folks, this is the boundary created for Makali City. So you can zoom in and zoom out. So what we're going to do next is to look at the attributes table for this Makali city. We can see that we have an ID, or we can still leave the ID. It does default, city name Makali, but we never knew the area. So we're going to create an area for our city. So for now, what we're going to do is to extend the attributes table so that we will be able to see a tab called field calculator. The field calculator is going to be used to calculate the area of our city. So we hit on field calculator. Here, we either going to create a new field or we update existing field. Since we have already developed a field called area So we're going to update existing field, then we click on the fields that are available, then we select the area field which we're going to update. For us to calculate the area or any geometry, we have to navigate to geometry under this search. We look for geometry. This is geometry. We have couples of geometry. We have the area geometry, we have the coordinate geometry, we have the length as well. So if you don't want to go through this, you just have to note that when you want to write any geometry, you should start with a $sign followed by the geometry name. For example, if you can double click, then this is the geometry. You will have a preview of the geometry in square meter. So this means your area is in square meter because we projected our map. But because we know that our area should be in square kilometer, we should have to do the conversion. And the conversion from square meter to square kilometer is you have to divide the square meter by 1 million. So to do this, folks, if we don't want to do all of this, we can still do it manually. We write the $sign, then we type in area. We use this area underneath. Don't use this. This is the field. Just use the one with area. Double click on area. We can have a preview of the area here as well. So because our area should be in square kilometer, we have to divide by 1000. So we hit on the division tool. This is the division tool. Then we hit on 1, 2, 3, 4, 5, 6, which is the 1 million. So the area is now 0.27 square kilometer. So this is the area. Then we hit on OK. So you will see our area is now 0.27 based on the tool precision that was given, 0.27 square kilometer. So we now close the attribute table. We have inserted the name of our boundary. Then as well, we have calculated the total area of our city. So we click and toggle off editing. Do you want to save? Yes, we want to save our map. Let's continue to save our map. So next, what we're going to do is to use a plugin that has been downloaded, which is the QGIS for us to bring in some of the layers. Like for example, you can see the streets from the base map. You will see the building footprint from the base map, but once you toggle off our open streets, you will not see them. This means it's only a raster file or it's a picture file, so we can't have the shape file. So what we're going to do now is to get this building footprint digitized. I don't think someone will have to digitize all of these buildings manually because it's a lot. So we have to depend on OpenStreetMap to have all of these buildings digitized automatically. So next, ensure that you have good internet connection. We click on the QuickOSM. Then this is the wizard for QuickOSM. Let's go to Quick Query. So this is very important for you to know. We have key and we have value. So key is the key element that you want to download. Then it has some other elements. For example, if you're going to download buildings, buildings is generic. For you to toggle which type of building, you have to toggle through either residential, commercial, public. So, but we don't want any of this to be differentiated. We just want buildings, be it commercial, public, we don't want to know. So that's why we're only going to use the key without filtering the values. So we click on buildings. If you want to download building, let's click on the first building here. So now this is the key. So this is very important. Where do you want to download the building footprint? So is, we have to click on this. We can download it using the canvas extent. We can download it using the layer extent. The layer extent is our shapefile. So if we click on canvas extent, it will only download buildings into this window that you can see here is the canvas. For example, if you click on canvas extent, you will see buildings like this. You will see buildings outside our layer. So that's why we have to toggle through what we think can be done. So we have to look at the extent for our area. So we move again to OpenStreet, Quick OSM, query tool, building. So here we're not going to use canvas extent, but we're going to use layer extent. In the layer extent, which layer are we going to use? We're going to use Makali City boundary to download our building footprint. Then when this is done, we click on run query. So our building shape file is being downloaded. You can see downloaded. Then we close. Then you will see the buildings within our boundary. Folks, you can see some of the smaller buildings that are outside, but it's better we have this than we have all of this, because it doesn't clip it properly because we have irregular shape. So what we can do next is to clip within our boundary. This is a geoprocessing tool that can be used further. So once we downloaded the building footprint, this is now a building shapefile. You can see it here as building. So this is not being saved into our memory. That's why you see in this icon here, it's a temporal scratch layer. It's not being saved. So we have to save this into our shapefile. So before we save this, I want us to save the clipped file, which is only within the building. So what we can do is to clip this building into our boundary. So to do this, we need to look for a window called processing. This is the processing menu. When we click on processing, we click on toolbox. For folks that do not see this processing icon here, it's very important. Let's say, for example, you can toggle this through the plugins. So we click on plugins, manage and install plugins. Then we type in processing. Type in processing. Let's go to install plugins. Yeah, processing. So you can see processing is being activated, but if it was not activated here, we close, you will not see the processing toolbar here. So that's why you need to, if you never saw it here, just make sure that you go to plugins, manage and install plugins, then you type for processing, then you check in the processing toolbox, then you close, then you can see the processing. So we click on toolbox, then we search for clip. So clip, we're going to use this clip, or we're going to use this vector overlay clip. Is the same. This is just because it has recently been used, that is why you're seeing it here, but you will see something like a Venn diagram on it. We have a couple of clips. Don't take this clip with the gear, but take the clip with this overlay. So we double click on the clip. Then what we're going to clip is the bigger feature. Then we're going to clip the houses. Then the overlay layer is what is going to be clipped onto. So we're going to clip building, then the overlay layer is going to be Makali City. So we're going to save our clip onto a file. So clipped, we left click, then we say save to file. Then because we have already directed our project home, it will directly go to GIS project and shapefile where Makali City is. Then we give the name of the building. We still save it as buildings. Then we click on save. Then we click on run. It says no spatial index exists for input layer. Okay, no problem on this. We have known that the clip has been done, so we close. This is not it's an error, but we can fix it out. But the clipping process has been executed. So for you to know whether it's executed, we will see different color for this building which is being clipped and it's not in any of the crash layer. So we can now remove this one, which is being downloaded from OpenStreetMap. We click on remove. You want to remove the layer? Yes. So we will now see that we have the layer for the buildings, which is within our boundary. We can zoom to layer for the Makali City, so we can see the extent and the buildings being downloaded. This is nice. So for the spatial extent, which was just shown as an error, or it doesn't have any spatial index, we can attribute spatial index to our buildings. This happens when you downloaded data from a bigger repository like OpenStreetMap. You have to configure it onto your project area. So we right click, we go to properties for us to solve the spatial index. We go to source, then we click on create spatial index. So when spatial index is being created, then we click on OK. So now we have created a spatial index for our buildings. So next, what we're going to do is to import road shapefile or road network for our project. So the same thing is going to be done. We click on Quick OSM, we click on Quick Query, then we search on for road network. So because nothing has shown on road, which means OpenStreetMap never used road as a key. So we change it to highway. So for highway, we have highway. Then the same thing, we move on to layer extent, and we're going to download it to the Makali city. Then we click on run query. So when this is run, it has been loaded successfully. So we can see the road network, which is being digitized within our area. So you can switch off the OpenStreetMap, then you will see this is the road network, but as earlier said, it was not saved into our shapefile folder. So we have to clip it to our boundary so that we won't have any of this extent of the road network. So we move on to clip as well. We already have it here. We double click on the clip. We're going to clip highway. We clip highway onto Makali city. Then we save the highway to file as road network. Road underscore network. Then we click on save. Then we click on run. No spatial extent as well. It's no problem. We close. Then we can remove the highway which is being saved as a crashed file. Click on remove. Do you want to remove? Yes, I want to remove. Then let me zoom to my Makali city to see. Then I have to as well create a spatial index for road network. Right click, go to properties, then you go to source, then you create spatial index, then spatial index created successfully. We close and click on OK. So folks, this is our city. In this city, we have a building shapefile and we have the road network. So if you as well want to change in the symbology, you can do it from what has been done from the boundary. We can change our symbology of the city. So let us look onto the building shapefile attribute table to see what is being saved. So under building, we have full ID and OSM ID, OSM type, building, yes. So this information is not much useful to us as it doesn't bring us different type of buildings, but this is the default brought by OpenStreetMap. So folks, what we're going to do next, we want to calculate the total area of the building in square meter so that we will be able to determine the buildings that are of bigger size to each other. So what we're going to do next, we already saw that OpenStreetMap has created fields. So we didn't create this shapefile from scratch. It was brought by OpenStreetMap. So you have to note two things. If you want to add any other field, we have to as well click on this new field. But since we are going to create a field called area, let us try to look at the process of creating the field. So the same thing, we have to start toggle editing before you see the new field activated. So we click on toggle editing, then we click on new field. In this field, one is going to be called area. This area is too small for us to calculate it in square kilometer. So we use square meter, M2, square meter. And the area, let's say it's still going to be into decimals of length 4 or length 5, then precision 2, which is the decimal point. Click on OK. Then we have our area fill. So next, oh, sorry, this is building. This is not road network. Great, this is building. So let's calculate the total area for our building. So this is the field being created. So we now go to open field calculator. We use the same existing field. We have just created it. We click on update existing field. Then we go to area. Then our area is going to be $sign to calculate the area, $sign area. We have the area here. This is in square meter. We don't need to divide by 1000 because it's already in square meter. So for folks that do not have the precision like this for us to, when creating the field, you know, we used 5 for total length and 2 for precision. So if you don't want this, you will just manually correct your decimal points by using the keyword here, which is called round, R-O-U-N-D. You round in each to 2 decimal place. When you click on round, you have the answer here, then separated by comma, then you put the number of decimal place, then you close the bracket. You will see it's 338.71. So this is the syntax that you can use to round your value to any decimal place that you want. You can say you want to round it to 4 decimal place, you will have 7.7082. You want to round to 0 decimal place, that is the whole number, you will just have 339. But for us, we just want it to be in 2 decimal place. The same thing goes to whatever you want to calculate, be it area or length of road network. This is the same thing you have to do. So we click on OK. But if you have already done that when you are creating the fields, that is, you specify the total length that it should be, as well as the total precision, then you click on OK. Then you will see that the area is now being calculated automatically from the system. So you will see areas of each of the buildings. So this is great. So next, what we're going to do, we have to hit on the toggle editing, or we click on save, then we click off the toggle editing mode. So we now created a field in buildings. Then let's look at the road network. If we open attribute table for the road network, this is great. We have couple of fields for the road network. Some are very important, some are not important to us. So let us toggle through and see. So we have fields like highway. This tells us whether the road is a highway or it's a residential. This is very important to us. The layer, we don't have anything on layer, so we have to switch off this field. Bridge, it doesn't tell us whether there is a bridge or not. We have to switch off the field. Surface, we have one surface which says it's an asphalt, so we can leave the surface field. The maximum speed, the lane, it's a 2-lane. Then the name of the road is as well very important, so we have to leave them. So we have to take off fields which we think are not important to us. So these fields will be, well, for the ID, I don't know how to understand. I don't understand these IDs, so I'll have to take off full ID, OSM ID, OSM type, because everything is just a way. Then I have to leave highway, I have to leave surface, I have to leave maximum speed, I have to leave lanes and name. For me to do this, I will have to go to organize columns with this pen, click on organize column. I switch off fields which I think are not necessary to me. So I leave name, yes, I leave name, I leave lanes, I leave maximum speed, I leave surface, I don't leave bridge. Layer, do I have something on the layer? No, nothing on the layer, so I switch off layer. Highway is very important, then I click on OK. So I have now got the right fields which I think should be retained from the road network. The same thing, folks, I'm going to create a geometry for the road network, which is going to be the length of the road network. So I click on Open Field Calculator. For this, I am going to create, I should have, yes, let's be consistent. Okay, I wanted to create a virtual field using the field calculator. But initially, you know, in the buildings, we start editing and we created a field. So now I'm going to use the other way of creating a field by using the virtual field. So I click on Open Field Calculator. There has never been a field called length. So I'm not going to use update field. I'm going to create a new field called length. The length is going to be in, because of this road, some roads are very long. Let's say it's going to be in kilometer, which means we're going to divide any answer being given by 1000. You know, this is just a linear measurement. It's not an area measurement. So we divide by 1000. If it was area, we have to divide by 1 million, because 1000 times 1000, we got something like 1 million. So this field is as well going to be a decimal. Then the output field, let's say we still need something like a 5 length and precision to be 2. Then what is going to be calculated here as an expression, we also know that we have to start by writing $sign, then we type in LENGTH, is going to be length. Then we click on this length. Then we will see a preview of the length that we have. So because this length, if we divide by 1000, is going to be 0.5 kilometer, for example, I think we have to leave it in meters. So if we leave it in meter, let's just say our field is going to be named length in meters. Yeah, so we can do it like this. So we're not going to divide anything. So we are not going to use round, because we already have this column, which is going to round our answer to 2 decimal place and a total length of 5 characters. So we click on OK. Then we have the lengths calculated automatically for our road network. So next, we close, and because we already calculated fields there, we have to toggle off editing. We want to save. Yes, I want to save. Yeah, so what I'm going to do next, you know, for our city, to be complete, we have road network, we have the building, then we should have river network. Unfortunately, we never saw any river network within this. From even the map, even the base map, there has never been any river network. So what was done by surveyors, they went ahead to collect GPS coordinates of a river network that flows on the south of our city. So what we can do is to import that file which is being given to us by the surveyors or by the hydrologist. We're going to import it as CSV file. Then we have to manually create our river network and digitize along the point file which is being given. So we can minimize and move to our point file. So this is the point file given by the surveyor. It's called river point. Let's copy this file. It's a CSV file, and keep it into our GIS projects. We keep it under raw data. Let's right click and paste it there. So let's delete this. We should have just cut it. So we have the river point here, which has been given. So if we try to open this CSV file, it will show you the point ID, which is being collected, then the eastings and the northings. We can see that it's already in the same coordinate system for the projected coordinate system of our area. So this file is going to be imported into our map. To import a CSV map, let's close this and close our project directory. We continue on to our map. We have to save what has been done so far. Then we import our shapefile or our CSV file as a point. So to do this, we go to layer, we go to add layer. Whenever you want to add anything, be it shapefile or text file, we have to go to add layer. Then we have to go to add delimited text layer. CSV is a delimited text layer. So if we click on add delimited text layer, then a window will appear like this. File name, we have to go into our directory and click on the GIS project. We go to raw data. Let's select our river point. Then we open it. It gives you a preview of how the file is. So river point, this is okay, we leave it. And layer name, this is going to as well be called in our layer as river point, which is okay. We leave the encoding. It's a CSV file, yes. And geometry definition. If you don't see geometry definition, maybe folks, for the first time, you will see it's been collapsed like this. Ensure you expand the geometry definition. Then it's a point coordinates, what is going to be X and what's going to be Y. X is the eastings and Y is the northing. So we select under X, we select in the file is eastings. Under Y, we select in the file is northings. So the coordinate system is already in UTM zone 29 north because we say in it. So we have to configure it to the same coordinate system. If not, you will not be seeing this point. So to do this, of course, it's simple now for you. You toggle through the globe, then you select on 29 north, then you click on OK, then you will have the projected coordinate system which has been developed. Don't worry, when the file has been given to you, they will tell you the coordinate system where the file is being extracted from. So we click on add, then we click on close. So folks, you will see the points collected. It's been added here as river point. So what we're going to do next is to digitize our river point. The same thing that we did, we're going to create a shapefile from scratch, which is called river. Then we toggle through and digitize through this point. So to do this, we're going to save our shapefile in this shapefile folder called river. Right click and go to new. We're going to create new file or new shapefile, create a new. Then this file is going to be named as river network. River network. Then the geometry type is going to be line string. Then the coordinate system is the same thing that we need to do. We just toggle to 29 north. We click on OK. Then the name of the names that will be in the river network, we still have to use name. Name, there is the text. Then we click on add. So for the river, it's not an area, it's a length geometry. So we say LENGTH. We want to know the length of this river. Let's say it's now going to be in kilometer because the river will be spanning across the south of the city. So it's going to be longer. So we have to do kilometer as a unit of measurement. Then we need to say it's going to be a decimal. Then we say the total length is 5. Then the decimal point is just 2. Then we click on add. So when this is done, we click on OK. The same thing, we have created the river shapefile successfully, and this is the river network. You will not see it here because it's a shapefile created. The same thing, you just click and drag, bring the river network into our window. So this is the river network. This is the river point. Don't confuse between the river point and the river network. This means our river will be within the direction of this point. We have to connect them. By the way, we have to look at the point ID. Let us symbolize our point because the point will be connected based on how it was ordered. So if we want to visualize the point ID, we right click and go to properties, then we go to labels, then now there is no label here. We say it's a single label, then the value that is going to be labeled is from the attribute table. We say it's a point ID, then we click on OK. So you will see 0.1, 0.2, 0.3, 0.4 down to 0.12. It's a 12 point. So next, what we're going to do, we have already created a shapefile for river network. Now let's try to edit by start digitizing. So for us to do this, we right click, we go to toggle editing, then you will see the editor is now being activated. It says add line feature. Previously it was add polygon feature when we digitized the road, the building. And sorry, the city, it was polygon. Now it's road network, so it's add line feature. So we click on add line feature, then we start to click on the building. You can see something is snapping here like move. This happens because we have activated our snapping option. Like if you want to, for example, if we come to project, then we go to snapping option. If we toggle off this magnet, then we click on OK. You will not be able to see the magnets for the move that is capturing the point. By doing so, you might be digitizing something else, not the point. So for you to digitize feature, which you think should be at the vertex, like this, you need to toggle on the snapping option, then you click on magnets. Remember, these are all gray, it's not activated. So once you click on the enable snapping feature, it's been activated. Then what you want to activate is the vertex. You can toggle through. Do you want to just see vertex, or do you want to click on line? So let's just say vertex because they are points. Then of course this 12 is the tolerance which we can use. So let's just click on this and click on close. Then if we try to digitize, you will see the move magnet. So we start to digitize the points as they are in that order. So this is the river network. This is where the hydrologist traverse through to get this river point. So this is the end. Once we're done, we right click. Then you remember when we created the fields, we have ID, this is just that. Then the name, let's call the name of this river Makali River. And the length, we are not going to calculate it because it is it's going to be automatically calculated. So we click on OK. So folks, we now got our river, so we can save or toggle off editing and save. Then, yeah, so this is the river points. We can switch off our river points and only remains the river network. So let us use some symbology. Let us represent road network as brown. We use another symbol for building, or if it is like this, then we leave it. Then the river network as blue. So we start by giving river network as blue. We go to properties, then we go to symbology. This is symbol. Then we use blue for our river. Then we click outside, then we increase to 0.6. Then we click on OK. So this is our river network. So for the road network, let us as well use another symbology. Go to properties. This is the default road network. Let us use, okay, we have some beautiful elements here that signifies some amount of topo main road. Yes, let's just, okay, let's just use this for road network. Click on OK. So we'll be able to see that when this is dot with the dot slash line at the road network. So if we toggle off base map, you'll be able to see the road network. So for the building, let's see if we can do some tweak on the symbols. We try to use this other beautiful color like this. Then we click on OK. Oh yeah, so we have the building like this. Beautiful. So for the road network, I as well want to change it. I don't like it. So I have to go to symbol, simple line. Let's just say simple line. Then say for example, okay, this is the color. So I don't want this dash because something is here. Use custom dash pattern. I don't want any custom dash pattern. I just want to be solid like this. Then we click on OK. Oh, this is good. So yeah, so this is our map for our new city called Makali City. So I as well want to differentiate the color of the building based on how big they are. Yeah, so let's try to categorize our building based on the sizes for which we can see buildings of bigger size having different color, then buildings with smaller sizes having different color. So let's use graduated symbol for this. So we'll go to buildings, go to properties, then instead of single symbol, we have to use something called graduated symbol. Graduated symbol, it's like this. This is the color ramp, which shows that when it's being high, we have red, medium, and the like. So for now, we have 5 classes. Let's click on classify. Oh, the value field, we have to know which field we're going to categorize on. So we have to categorize it based on the area field, the total area. Then we click on classify. So for now we have 5 classes, 1, 2, 3, 4, 5, but let's limit it to 4 classes, so that we will have buildings categorized as very large, large, medium, low, something like that, or small, or say very big, big, intermediate, or small, something like that. Okay, so the legend, these are the total area for each building. So what is going to appear on the legend is from here, let's say buildings between 6 to 81 square meters are going to be called very small building, very small. Then here we have small. Then we have large. Then we have very large. Very large. Then we click on apply and click on OK. So you will see that on the buildings we have very small, small, large, very large. So you can see very small buildings are just white. These are the ones. They are very small buildings. These are white buildings. Then small buildings are something like light red to dark red, which are the bigger buildings. So this tells us that within this city, we have to the north of the city, bigger buildings, unlike to the south of the city. So this is how you're going to display our map. So the buildings have been categorized based on the sizes of the buildings. So I think this is okay this way. So we are now ready to export our map. So in as much as we have developed the city called Makali City, we have developed the building footprint, we have as well developed the road network, then the river network, then we have categorized our buildings. Our map is now ready to be exported. So before you export our map, make sure that maybe your map is like this before you export. You have to zoom to layer so that you will have the full extent of our city. We go to Makali, we zoom to layer. Yeah, so when this is done, we now try to go to our print layout. We go to, let's save our project, save. We go to project, then we go to new print layout. New print layout. Every layout has a name for recognition. So this layout is going to be Makali City layout. So you click on OK. Then you will have our layout like this. For now, it's too small within the window, so you can expand it to window size like this. You click on zoom full extent. Then we have our layout like this. So for us to have elements into our map, you need to understand key things. One is the select tool, which is the activated one. Then we have another tool called move ITM. That is when you click this, you'll be able to move ITMs within the map. Then we have add map. When you click on this, when click and drag here, you will see your map display. Then this is the text which can be used to add your labels for the map or title. This is the legend to add legend from the map. and this is the scale bar and north arrow. So key map elements that we want in our map is the title, the legend, the scale bar, and the north arrow. So let us first click on add map. We click from the top down to the bottom right. So this is our map. So because we want to have area within our layout for us to insert what has just been discussed in terms of the legend, the north arrow, the scale bar, we have to shift our map to the left so that we will have some area available for our title block. So when this is done, we can still zoom to layer because the map for me is too small on this display. Yeah, this view to me is not too big, so I want it to be zoomed into the extent that I want. So what I will do, you can observe that when I click on this map, you will see there is a scale here, which tells you that this is the map extent that we have. So we all know that the bigger the scale, the smaller the map, and the smaller the scale, the bigger the map. So let's change. This is just trial and error. We just try to change what we think should be on the map. For now, we want to enlarge the map, so which means we have to reduce this scale. So it's now 8. Let's say we want to 8431. Let's say we want to toggle it to 7. Click on 7. Then we click on enter. So it's enlarging gradually. So let us reduce it to 5. Yeah, this is better, but maybe 4 will be good. 4. Yeah, so this is exactly what we want. We have enlarged our map based on the scale. So next, what we're going to do is to insert key map element. So we start with the title, we click on add text, then we just try to draw our window here. Then this is, it's just a default text. If you want to edit this text, we will see label. As soon as you click on the icon here, you will see an edit window appearing. So we say map of Makali City. Map of Makali City. So folks will agree with me that this font is too small. So if we click on it, we can tweak it. So for us to enlarge this, let us look through this label. We have some couple of things that are here. So if we look, I'm trying to toggle through under this label. I have something called font. So this is the font. So if we try to scroll up, you will see the font enlarging. If we try to scroll down, the font is reducing. So we scroll up until we approach a desirable font that we want. So maybe we leave it like this. Then we have our map of Makali City. Maybe we drag it down a bit. We reduce this. So map of Makali City. This is great. So next, what we can do is to add our legend. Before we add the legend, let's go. Of course, we just come to QGIS. If you want to go to this map, Makali City, this is the layout that we are. Then if you want to go to the QGIS window, you come to the left, GIS project. This is the GIS window. So exactly what you see here will be your legend. So if you think these names are okay for you, then we can leave it, then we proceed. So your legend will appear exactly how it is being organized here. So we move on as well to our layout. Then we click on add a legend. Then we just click on the window, click and drag and extend it to wherever you want the legend to be. Then we can click and drag above for us to be able to visualize it properly. Yeah, so we don't want some element. For example, we are seeing river point, which is not in the along the river network. So when you as well click this, you will have legend item. Whatever you click appears here. So for example, let me see if I can increase this above a bit, then have this guy as well moved upward. Let me see. Yes, I can move it above a bit. Yes, so let this guy be like this. Then I click on this, then I will have the legend properties. So I will have to remove elements which I think should not be included. So when you click on legend, you just navigate downward, you will see a list of elements that are included. So this is river network, you can remove it. So for now, it's not on sync, only show items inside. So this is the legend, it is under auto update. So you will not be able to remove when it's on auto update. So you just check out auto update. Then if you click on river network, then you click down, you will be able to see the remove tab to remove any selected item. But if it was on auto update, you browse downward, all of this will not be shown. So we click on auto update. Then we select what we want to remove. We want to remove river point. Then we click on remove. So the river point is now being removed. Again, we can add a title of our legend. For now, you can see title. There is no title under the legend. We just write legend, Legend. As you type, you will see the legend appearing. If nothing, you can't see anything. So as you type, Legend, you will see the legend appearing. This is nice. So now we have achieved the development of our legend. Then let's see what we can do with the scale bar and north arrow. The same thing, we click on the add scale bar. Then let's just click from the left to the right. This is our scale bar. So the scale bar is in meters. We only have 2 units. This is fine. But if you observe our scale bar, it's something, it's like it seems to be outside of our map. This can be configured. So once you click on scale bar, you will have the scale bar properties. So the label units multiplier is just 1 unit. Then if you come down, you will be able to see fixed width. The reason being that it's fixed width, that is why you're seeing 100 here. So let's say we want to use 90. So if you say 90, you will have it reduced to 180, because the fixed width here is, it says for every scale here, it's 90, which is 80. So that's the fixed width. So we can as well say, let us have it 50, 50, 50 to have lots of the width. Let's say by 50. 50. Delete. Yeah, then we have 50, 50 in this order. Then next, you can adjust the length of it. For now, we can see that the fit to this is 50. This is too large. Let's say we want to see where it is. It is 600 by 600. Then we have to reduce this length. It is now 50. So let's say we want to reduce it to 20. Click on enter. Okay, this is 150. Let's say we click on 50 here. No, sorry, this is 500. We click on 50 here. So you will have the fixed width as well. So you just have to play with it. So we still have this unit. So we can still reduce it as we did initially. Let's just have the fixed width in terms of 90. This will be better. Then we have the fixed width as 90. Okay. So I always like the scale bar to be underneath the legend, so I want the legend to be here. Then the scale bar, I right click, click and drag. The scale bar should be at the bottom. Scale bar. Then I have my legend on top of the scale bar. Top of the scale bar. Then I will have my north arrow. Let me just draw anything like a north arrow. I will have to increase it if it's not okay by me. If this north arrow is not to be used, I will toggle through the series of north arrows that are here. I have a couple of north arrows. I have this. I have this. Maybe I can just select it. North arrow. So yeah, for the purpose of this, let's just limit workflow to remain on this. So we have the title. We as well have the north arrow. We have the legend. Then OpenStreet, I don't see why OpenStreetMap should be here. Let's remove it. We click on OpenStreet. We click on the legend. Then we navigate down and try to click on OpenStreet. We remove OpenStreetMap. So we have Macality, very large, large, small, and the like. So I want always this building, because when someone says building, they will think Macality is building. I want this Macality boundary shapefile to be on top. Then later we have the building. So I will still do the same thing. We adjust the order. We click on Macality, then we move it upward. We click on the arrow upward. So now Macality is upward. Yeah, so this is now great. So when I say buildings, all other things beneath are the buildings. So if you want to write anything regarding the author, the date, you can just toggle through your add text. Like for example, I have to add text like this. Map developed by ABK, for example. Map developed by ABK. Then I put my date. Today's date is 19th of November 2025. So map developed by ABK, I will try to extend it. Map developed by ABK, then I have to extend this so that I will see everything here. Map developed by ABK, then before the date, I just say date, then 19th November 2025. So anything that you want to add when it's annotated text, you can use the add text icon. So when our map is done, this is very nice. So map of Macality. Can we add something? Map of Macality showing building and road network. Maybe this will be an assignment. So we can now export our map. So we click on save. Our layout is now completed. We click on layout, then export as image. We can export as image, we can export as PDF, but now let's export as an image. We click on export as image. It directs us to our GIS project. As we said earlier on, we click on processed. Then we say Macality map. Macality map. Then we click on save. So this is the dots per inch, the resolution. If you want it like that, it's good. Then we click on save. Then our map is now being saved. Thank you very much, folks. So we can minimize the map and minimize the layout, minimize the map. We go to our project folder, then we now open the process. We will see our map of Macality. When we double click, we will now have our beautiful map of Macality created from scratch. So thank you very much, folks. I hope you enjoyed the video. If you have any comments, make sure you write it down to my channel for more updates on successive calls. So thank you very much. Goodbye. Have a nice day.